We'll see if we can crash my computer. All right, from the top, welcome everybody to February. I hope that your 2021 is off to a roaring start and looking extremely positive and as a big improvement from 2020. It's early to say yet whether we're on the right track, but I hope everybody joining us is enjoying the year so far and things are looking very bright and positive. Today we have Andrew Kirkpatrick. He is a long-term contributor to the community, DevOps Day speaker, I believe DevOps Toronto speaker as well, but I might be incorrect about that. Anyways, he's been sharing ideas, learnings, wins, failures for a long time and been a really important part of this community. So he's sharing some of his latest with us today. And I will hand over to him very shortly to introduce himself and kick off a presentation. As always, our sponsor again for 2021, JFrog, has a bunch of events coming up and they're looking for speakers. So jump onto that link and check it out if you're interested in giving a talk. Again, as always, I'm happy to help you out with any proposals, with any speaking opportunities that you've got. I've learned a lot of hard lessons over the years and I'm happy to help out wherever I can. I love to see more Toronto and local voices contributing to events and conferences. Even if you've got a company webinar coming up, or if you've got, a talk to your team coming up, let me know. I'm happy to give you a few pointers, some easy tricks that I've learned over the years. So these things I think are huge opportunities, especially if you're looking for a boost in your career and your visibility. Speaking at a conference is humongous. So I would encourage you to jump on these opportunities whenever you can. I know that public speaking is the scariest thing in the universe, but it's only scary the first couple times and then it gets better and better. I'm living proof of that. I used to be terrified of this. So with that, I'm going to jump back to Andrew. I'm going to stop sharing my screen. I'm going to hand off to him and let him take over the show. Once again, thank you for joining us. Very pleased to see everybody here. Jump on video if you want. It's great to see everybody, so feel free to stay video off, but it's great to see everybody join us. So I'm going to kill my screen share, hand over to Andrew, and he can take it from here.
All righty. All right. Everyone see the screen? Audio
looks
good?
Great.
Fantastic. Alrighty. So to kind of sum up the theme of the talk, maintaining a whole infrastructure with Terraform and using reusable modules makes most of our lives easier for anyone that uses infrastructure as code day to day. But when those kind of people that are less familiar with DevOps want to create or update resources, you usually either have to train and enable them to use Terraform, or you have to handle those requests yourself. However, what if you could offload the execution of those changes to a centralized tool and just review both the code and output being submitted for review? This is something that kind of I've seen pop up in a number of communities just in terms of reducing the amount of shoulder taps you get. So, and I've used Atlantis at a previous job, so decided to take a look at Atlantis, Terraform Cloud, and M0 as tools that can act as a PR-based feedback loop for using a hosted Terraform executor to make kind of self-service for users and developers a little bit easier. So, I mean, as an introduction, infrastructure as code solves a lot of problems for us in terms of reusability, like reproducibility, things like that. Having everything codified is great in a lot of cases, but it doesn't solve all of our problems, right? The kind of interruptions and just sheer number of noise that a lot of DevOps or infrastructure engineers get on a daily basis is still pretty intense in a lot of cases. And there's a lot of legitimate reasons why these change requests might come in, right? It's the same reason why we make changes to infrastructure. Like they might need more VMs for stuff. They might need to change capacity for things, user accounts, service accounts, DNS changes, CDN changes, all this kind of stuff. Like there's all sorts of reasons why they might want it. And you don't necessarily want to keep yourself as a roadblock for them being able to get on with their jobs so that you can get on with your job. So what's really important to keep track of? So kind of historically, and I mean, this is a generalization, so don't don't attack me for this, but the reason that sysadmins in the olden days got to do a lot of this stuff is because they were the only people with the expertise to carry out the changes correctly. So you wouldn't necessarily trust, junior engineer Bobby to do X, Y, and Z in the data center on bare metal because you needed to make sure that uptime was critical. But what if you could automate a lot of that danger away? So like what is really important to keep track of? So you want to make sure that those changes are performed safely so that they're both reproducible and there's safeguards, and securely so that you're not making changes that are theoretically dangerous or introducing any kind of problem. You want to make sure that they're tracked in some way, whether that's on an individual level all the way up to like a project or division level. You need some way to track back who did what, where, for what purpose. And that ties into things like issue tracking systems. Codified in a reproducible stream of changes. Like this is, for me, number one, so that I can see if you made changes to something, at what point was it made, what's the upstream and downstream change of that. So like, how do I reverse it? If configuration is drifted for other reasons, how do I reapply what I believe to be the correct configuration for something? And then similar to how most engineers write code, how do you implement some kind of peer review process? And who actually gets to review that? And a lot of that hooks into like version control system, built-in mechanisms, such as pull request reviews, code owners, things like that. So why would you automate Terraform? As we know, like using HashiCorp control language, that's just a DSL, which you can use to describe a lot of things in your infrastructure. I personally have a preference for using modules to try and abstract a bunch of that stuff back out, to try and encapsulate a lot of complex domain-specific logic. That's potentially one way to allow people to contribute more without having to know the specifics and the nitty-gritty. And if you did that, how easy actually would it be in practice to allow people to like create resources, modify or delete resources if they're only changing a very finite amount of configuration in Terraform at any given time? And if you did that, how would you validate what they were trying to do? And how would you approve what they were trying to do? So in terms of a validation step, like if you think of the typical Terraform commands, you want to see what is it trying to do? So Terraform plan, what are you going to create? What are you going to modify? What are you going to delete? So how would you get something to validate what you're about to do? And how would you get it to automatically revalidate what you're about to do? So as you can see on the diagram at the right, Atlantis handles that by essentially just continually running against new commits on a PR. But I'll have examples of all of this stuff later, so I can run through it in much more detail. So don't worry, like if I kind of skip over stuff. Also, this presentation is on SlideShare, and I've got the link at the end. So if I'm skipping through stuff too quickly, like it'll be there so you can pull it up for reference later. In terms of approval, I mean, Atlantis specifically on GitHub, and I believe for Bitbucket and GitLab, uses a similar process where it will check for approvals, and it will or won't action things based on whether the PR is or isn't approved. That being said, VCS systems can integrate into issue trackers as well, so you can then tie this PR against Jira and have like a kind of automation flow set up that way. But that's very individual, but that's kind of, I mean, that's relatively speaking, I would say best practice anyway. So how and when do these proposed changes occur? So as a summary, what are we going to talk about today? So I'm going to cover off Terraform at a glance, like really quick top level for anyone that's not used it before. It should be fairly familiar with anyone that uses it day to day, but just to cover off basic concepts. So in enough context for the rest. What does self-service infrastructure look like? Like what kind of concerns would people have if they were asking for stuff themselves? Since Atlantis was the first of its kind, how does that compare against Terraform Cloud, which is recent, and then M0, which is even more recent? How do pull request workflows even work? Like if you're not running something on your desktop machine with the correct credentials. How does that even work if the execution is taking place elsewhere, which hooks into centralized execution? If that's running, what kind of potential concerns, drawbacks might you have with that? Examples is going to be some videos that I pre-recorded, workflows on actual repository that I use to control our infrastructure. So just kind of walk you through what does this stuff actually look like in practice, like if you were actually to do it. Some of the advantages and drawbacks of just this as a general concept, and we'll kind of dip into the pros and cons of each as we go along, and then a rough summary of what would you choose for any given scenario. Like just because we chose Atlantis and I have a preference for Atlantis doesn't mean it's right for you. Like Terraform Cloud has some really neat features and it's a much more fully featured platform. And M0 has a kind of a different take on things, which may or may not suit your use case depending on what you're doing and what scale you're at. And if absolutely nothing else, and you take nothing away from this presentation, at least you didn't have to put pants on to listen to me. So that is a plus. So Terraform at a glance. For anyone unfamiliar with it at all, it's essentially HashiCorp control language, which is a domain-specific language, which blah, blah, blah is basically how do I describe things that exist in my infrastructure? Typically the cloud. I use it for like IAM user management as well, like GitHub repository management, almost anything that there's an API for and that either HashiCorp or someone else has written a provider for, which is just an API abstraction. You can get it to control and manage, give or take anything. But the providers for all the main cloud companies are pretty good. Like the AWS, GCP, and Azure providers are all pretty solid and control a majority of the infrastructure that you can handle there. And the one thing to bear in mind, which is why I'll kind of touch on why this is complicated to do in a CI/CD environment versus having a tool that has stages to it, is the state triangle, which is a term I completely made up. But this is kind of how I think about it. So I would typically think of like the code that you've got checked out in your repository on your machine at the time you run it as what you want to be true. State is what was last known to be true. So essentially what you're going to do is going to be a difference between those two. So if there were servers there and now there's not, you want to create them. But if I have servers and there weren't servers before, sorry, that example's backwards. You know what I mean? It essentially knows whether to add or delete stuff. And then the APIs themselves is the underlying abstraction which the providers talk to. So like if I've got the Google Cloud provider and I want to create a compute engine VM, that's the actual kind of like magic secret sauce that goes, okay, I'm going to transform this code block into API requests that will create the server for me. Or if I make any changes and Terraform calculates a difference, it will go, okay, like I want to change the base image for this or the instance type for it, things like that. So as I said, I mean, Terraform is dead simple at the top level. You've got the initialization, which basically just preps things. So links in modules that you're using, downloads to provide the actual API clients themselves, called providers, and configures remote state, which we'll touch on in a bit. Plan does basically everything but the actual work. So check what you've got versus what's actually in remote state, work out the difference. So essentially figure out what it's going to try and do based on what's in state, which was what was previously true, what you now want to be true, and then essentially figure out, like present to you an output of like, I'm going to modify this, I'm going to create this, I'm going to destroy this. And then apply runs an implicit plan nowadays, and then I'll attempt to actually do those things with the API. I think it differs to provider, how much of that stuff is checked at plan time and how much of it is actually checked at apply time. So sometimes you'll get plans that look totally great and then you'll apply it and then you'll either get collisions with your configuration isn't actually valid or you're trying to create stuff that already exists, a bunch of the other stuff. So apply is like the main meat of I'm going to actually do stuff for you. And then I'm going to update state to reflect so the next time someone runs, what I've just done now becomes what was previously true. So remote state is basically just a bunch of JSON that describes the code that you have versus what was actually returned from the APIs. So what actually exists for real as far as it's concerned. Typically that's stored in like an S3 or GCS bucket, but there are a bunch of other different backends. Like I think you can store it in console, and Terraform Cloud offers an enhanced backend, which we'll touch on a bit later, but essentially it's just how do you store state not in state files on your local machine, which is the default. So like if you're going to work in a team environment, your understanding of what was last true needs to be consistent across your whole team. or anyone that executes it. And in a PR-based environment, that also needs to be true for the central executor that is making changes and reporting them back onto your PR. So everything, if you make local changes, that needs to be in sync with what then happens somewhere else on other people's machines or on a PR. So as a real basic example, as I said, for anyone that's not seen it before, if I wanted to make a storage bucket, here's some basic configuration for it. You can see that bucket doesn't exist. Init just pulls down the provider, which allows me to talk to the Google Cloud API. And then the plan just says, I'm going to go and make this. So this is a combination of stuff that I've detailed explicitly, like the name, the location, stuff that defaults, like force destroy, storage class, and stuff that is computed programmatically. So like you won't know the ID of the bucket until it's created, and Google Cloud tells you what the ID was, and that will be available as an attribute back on that resource later. So I apply it, magic happens, and the bucket appears. And that's literally it. So you get an implicit plan. It will tell you the same information again and just prompt you, are you sure you want to do this? As anyone that uses Terraform knows, that is probably the single most important thing you need to check. And then the reverse example of that is you strip out the code. It'll be stored in remote state, but it'll see that it's missing in code, work out that that means you're trying to destroy it, and then destroy it. So why would you want people to be able to do this from themselves? Aside from the fact it'll save you time and a whole bunch of toil. So who typically develops with Terraform? Probably most people on this call, usually people like us. But application engineers will typically just write application code specific to wherever you're working. And that often results in the thrown over the wall anti-pattern, which is, I've done my work, which is very important. I want you to go and do some other stuff for me because I said so. And then vice versa, like you've written crappy application code. Can you make it so the database doesn't crash? And that kind of creates a whole bunch of friction, which no one really wants, right? So we either want them to change things with their application to prevent some problems, or they want to change infrastructure to facilitate certain things. The observability piece, I'm not going to cover into today because there's heck knows how many other presentations on that. So let's focus on people being able to actually implement changes to the infrastructure so they can get on with deploying their application, adding new features. And that typically comes in a whole bunch of forms like Jira tickets, Slack, email, all this kind of stuff. How do we stop them from bugging us? So let's make a self-service process for them that, again, to kind of circle back, how do we validate and approve the changes they're trying to make? So as I mentioned initially, like there's an awful lot of resources that you can get in Terraform. At this point, it's kind of overwhelming in the same way that AWS is overwhelming. Like how do you get someone to build a VM, or how do you get someone to build like an ASG that sits behind a load balancer that gets assigned an elastic IP that they can just kind of go, all right, I want this for this image, pipeline it, throw it up with minimal complication. So one way to do that is kind of abstract it behind modules. So just make things that they're kind of caring about configurable and kind of hide the complexity of the rest. So I kind of typically think about this in terms of things that are either globally configured, so kind of pre-configuring resources that are specific to your business, like your infrastructure, your organization. Like how do you want VMs to be configured across the business? Stuff that's dynamically configured, so like you can do kind of fancy things with like lookup maps, locals, things like that. How can you kind of interpolate configuration based on stuff they provided? Like if you let them specify an environment, can you pick like specific logging options for that? Can you pick specific instance types that are allowable for that? Things like that's for stuff that they don't really have to think about. You just say, enter the word dev or prod in here and it will just configure itself automatically. Or stuff that you want them to configure individually, like names. So kind of as a real basic example of that, say we've just got a DigitalOcean droplet. There's a bunch of default options there. And then how could you kind of compress that into the module on the right, like simplifying it down? So let's say I never want to let them pick the image for it because it's always going to be Ubuntu. I never want to let them pick the region for the VPCs. I don't want them to have to know VPC IDs. So you could either use a data source to look that up, or in the case here, I'd use locals to pick it based on the name. I'm interpolating the vCPUs and memory into the size so that I can kind of basically stipulate a simpler way for them to understand how to pick an instance type. So just little things like this, like how do I make it simpler for them to contribute without them needing to know exactly how Terraform works or how all the configuration for specific resources works. All right, so enough about that. Modules are great, Terraform's great. What options do we actually have? So as said, Atlantis was the first. That's been around a little while. I believe that caused the author to be hired by HashiCorp. I may be wrong there. Terraform Cloud is kind of born out of that, I believe, as a result. There are a bunch of differences between them, but Terraform Cloud is a hugely impressive platform in terms of what it can do, but it's not feature parity as such. Like Terraform Cloud provides you a bunch of features in terms of remote execution. Like the remote backend actually allows you to run plans locally and have stuff execute in the cloud, which is kind of neat. The approval process is different. It's got a private module registry, which is great. It makes things a lot easier if you're developing reusable modules throughout your organization. And then on the flip side, N0 is very, very new, I think less than a year old. And that kind of takes the concept of if you wanted to have kind of copy-paste environments that are short-lived or long-lived or kind of multiple replicas of stuff. So say if you wanted to stand up like a full data pipeline with like a bunch of boxes, servers, databases, all that kind of stuff, and have it torn down within 24 hours, it kind of supports that kind of workflow, which is kind of nice. So what is Atlantis? This is taken from their website, bloody. What is it really? It's the first PR-based Terraform automation tool that I'm aware of. Whereas like you can download this and it will do this stuff without you having to rig it up yourself. Runs in a container as expected, but it's a Go application, so you can deploy it how you want. It only responds to webhooks from major version control systems, so GitHub, GitLab, and Bitbucket. So it doesn't really have an interface of sorts. It will just wait for these webhooks and do things based on what it's been told to do, which is typically code was changed. I need to figure out, based on what code's changed, what I'm going to do with Terraform, and then report back what I did. So you can configure it with multiple repositories. You can configure multiple projects per repository. And kind of the key wins for me is you can have fully custom workflows. So if you do any bizarre things in between sort of like Terraform, init, plan, and apply, you can kind of script it all out and get it to do whatever you want. Terraform Cloud has an even longer description. So it is kind of a cloud-hosted platform that sits up there. So you log into Terraform Cloud, authenticate with HashiCorp, and then you have a few choices depending on how much money you want to pay. So either you can have like the control plane and remote execution handled all in the cloud. I think Business Plan allows you to have a cloud-hosted control plane and local executors, or if you go for the enterprise plan, you can have both hosted yourself, I believe, at the time of writing. The private Terraform module registry makes things a lot handier if you're trying to promote module reuse. The enhanced backend, as I mentioned, has a bunch of extra features on top of the other remote storage states. But it is a little bit more complicated to set up workspaces. From what I can see at the moment, there's no way to do that in code unless you drive it from the API itself. But that being said, like they have a fully featured workflow system, so you can hook it into version control, or you can drive it from the API, or as like a CLI tool to power it from. So it's a bit more fully featured than other stuff. What did I figure here? Oh, confirmation step. So this is kind of a pro or a con, depending on which way you look at it, but it's got confirmation steps within Terraform Cloud itself as to who, like if you're going to do something, who is allowed to confirm whether that's what you wanted to do, apply it, things like that. Kind of useful. And then that will then go ahead and do that. You can disable destroy plans, which is useful if you want sort of people to be able to do things fairly freely, but not accidentally nuke stuff. It also has more notification options than the comparisons. Like I think there is a beta Slack notifier for Atlantis, but nothing else. But this you can post back to other systems. So if you want to get really fancy with Jira integration or something that's not Jira, i.e. preferable, or you can have emails set up to kind of notify you like your environment was set up, it was torn down. Projects can't contain symlinks, which is really annoying. So I typically symlink TFRs files into auto TFRs files to save me copying stuff all over the place. That doesn't work here because apparently they're not a fan of it. So if you have any symlinks in your project, as soon as it tries to clone the repository, it will fail, which is frustrating. It only supports enhanced backends, which is, so if you've got remote state in S3 or GCS, it will not work. You have to switch to the Terraform Cloud remote backend, which is fine because that still works locally, but then kind of you're kind of hooked into this system. So it's just something to bear in mind. Otherwise, you'll get like weird inconsistencies, like you can see here. Like it can't tell. So what's M0? I mean, this one kind of makes more sense as you read it, but fundamentally, it kind of has a few different names for things. So it creates what it calls organization template. So it expects you to have like a stock standard set of projects or project in a repository and wants you to create sort of 1 to n workspaces on top of that. So you create a project environment from a template, and then that will then create a workspace for that. And then you can spin up stuff just kind of on the fly. So you can either set it to be permanent or set it to be temporary. Say, I want you to make a new workspace with name Andrew, and I want it to be short-lived for 24 hours, and kind of configure it that way. From what I can tell, there's no other way to set up workspaces other than through the UI or an API at the moment. So similarly, you can't drive it through code. And it's relatively new, which is a pro or a con, depending on how risk averse you are. So like having environments as workspaces is kind of nice, but if you're not a fan of the workspace kind of concept, that can be a bit of a drawback. But it is nicer just being able to spin up kind of carbon copies of stuff if you want people to just be able to throw up like exact same stuff. And that then kind of creates environments which you kind of see a similar workflow through here. So like this environment is active, it's going to watch for changes to this code, which theoretically means if you're pushing changes to the underlying code, it's going to update all environments. So if you're letting people bring up like dev environments as a project environment, it means you can kind of push changes out, which syncs to everything, which could be really, really nice if you've got, say, like 30, 40, 100 copies of this stuff. But I've not tested it at that kind of scale because it's quite new. So I have no idea if that actually works that well in practice. There are some neat features in terms of stuff like cost management. So because you can spin up 1 to n environments, it will track like how much you're actually spending on all of that stuff. And you can like pre-configure when you want these environments to destroy, which is kind of nice. You can set kind of project policies, which I think at the moment is just like for any given user, how many environments can they spin up? So prevent people just spinning up like unlimited dev environments and different approval processes. Some of the gotchas is that it does not support remote state at all currently, which is weird. So it will capture state changes that happen locally, same as if you don't set up a remote backend, and then just copy it into itself. So M0 is only aware of things that were done in M0, which is kind of like a big stopper for me, but it may not be for other people. Otherwise, I mean, it's pretty nice if you can get on board with the workspace concept, like depending on how you configure it. So I think it's going to depend if you're starting something greenfield or like if you've already got something that kind of fits into that mold. Everything supports variables for the most part. Atlantis is the only one that can support file-based configuration, which again can be a plus or a minus depending on. Like I use it for Kubernetes config configuration because it's easier. So you're kind of limited with what you can do for that. Again, depending on whether you think that's a good idea or not. So pull request workflows. Also, weirdly, I was looking for a picture of a guy pulling something like a strongman, and apparently dog pulling is a sport that exists. I don't know why, but yeah, very odd. Why you get dogs to pull heavy weights seems kind of cruel, but an interesting picture. So what about using CI? So a lot of people, like prior to Atlantis, were trying to build this stuff into like Circle CI, Jenkins, and that for a lot of people works, especially if you want auto-approved workflows. But some of the problems you get with that is depending on how you're handling execution of things like Jenkins, synchronizing your plan and apply steps so they actually happen with the same code with the same state can be an issue. The approval step is a bit of a potential hiccup. Like, do you want stuff to just automatically go through when it's merged in? If so, that's cool. But if you actually want to check what's about to be changed before you accidentally delete your production database, that can be an issue. and which project are you going to plan. So more of an issue for monorepo type setups, which is like, say, how I'm currently using something. So unless you've got one project per repository and you have a very limited amount of stuff, you'd have to build in logic for it to figure out what am I supposed to plan on based on what files changed, which again is kind of stuff that all of these tools have solved, but it's something you'd have to figure out. So the way that HashiCorp themselves describe it is you need to make sure that in theory, you're only planning one project at a time, so that like the plans, especially if you're outputting plan files, that they don't like drift out of sync. So if two people have submitted 2 PRs against the same project, changing different things, how do you decide who gets to make what change? So that's kind of a potential issue. Approval of plans, as I mentioned, if you're running a CI, how do you add a step in to go, okay, I'm happy with this, I want to let it go through. Like some CI like CD tools have manual gates on them, but like that's one of the big pluses for Atlantis for me, is that I can very easily see what's going to happen, approve it, and get it to happen. Also, if you kind of run something straight through and it breaks, you've potentially got broken code on master or on a release branch. So that can, and that's an issue with M0 and Terraform Cloud anyway, based on the way they work. So that is potentially a problem. Pull request feedback. So Atlantis itself will kind of output stuff back to you. So will M0. Terraform Cloud will not. So there's not an easy way without going into Terraform Cloud to see what it's about to do. Whereas the other two will kind of report back and give you similar output that you would see on your terminal. So that's kind of nice. Only Atlantis and Terraform Cloud have status checks. M0 does not, but they kind of show up as typical pull requests, like I've planned something, it's good to go, or like I have not, I can't because there's an error with it. So kind of just familiarity for developers there. In terms of execution locking, Terraform Cloud will lock each workspace as it goes along. Atlantis will lock each project as you've configured it. M0 won't lock because it just creates overlapping workspaces for stuff. So that's kind of just a design paradigm difference between the two. The Atlantis locks, it basically just gives you instructions as to what's going on. So for example, this is my sandbox DNS project. Basically says someone else is trying to make a change for this. They came first, therefore that workspace is locked. I'm not going to let you plan or apply or do anything until locks have been released. They're separate to Terraform locks, to remote state locks themselves. It's just locks that it keeps track of itself, just to basically make sure you don't, like, it follows the sequence of PRs that have been submitted in the order they were submitted. I think it could be random. I can't remember. In terms of reply requirements for Atlantis, say specifically, you can set whether it's got to be approved and mergeable, so won't conflict, and then it'll let you apply. If for any reason it doesn't, then it won't let you apply. But that being the conceptual difference between the two, in that if you, like, for Atlantis, it expects you to apply and have those changes applied before PR merge. For the other two, it expects you to only see the plan before you apply. And then it assumes that the plan is good, and then it will apply once it's been merged into the branch that's been told to pick up the detected changes on. So as I said, that is either a pro or a con, depending on your viewpoint. I don't like it, but other people think it's fine, depending on how much code you've got, all that kind of stuff. So centralized execution. Where is this stuff actually running? So Terraform Cloud, as I said, you can run either with agent pools in Terraform Cloud itself. Atlantis just runs within the container that you run yourself typically. M0 runs in Magic Land and will just kind of happen. So you kind of have to be on board with that. Like, so if you need something on-premise, Atlantis or Terraform Cloud Enterprise are your only real options. So the biggest workflow change is you don't authenticate as yourself anymore. So you need service accounts or just general robot accounts to kind of manage this stuff for you. And there's inherent risk with that, right? So you have to give over control of what you're going to control to something and be able to limit the scope of that, which not all providers support, because not all APIs support it. So you kind of have to look at what you're trying to control and then adjust accordingly. So like I have Google service accounts that are scoped to only allow DNS changes to particular zones, only allowed to like have read-only permission to my networking information. They can't make networking changes, things like that. So I have multiple provider block cell like this, but this is why Atlantis for me is kind of useful, because I have my Kubernetes configuration injected as like a file-based secret that I then get it to read. So I can run one instance of Atlantis somewhere and have it read, like I have it read ingress IPs directly out of all clusters I have, so that it can update that IP information in Cloud DNS, Cloudflare, Route 53, which is kind of useful. But anything you can configure in Terraform, you can configure in most of them. It's just how flexible that is varies between them. So like this is literally an example of how I'm injecting it in GKE. So this is how I'm running Atlantis. This is how I inject the keys in. Should I be running Vault? I will be soon. We are hiring. If you want to help set up Vault, that'd be greatly appreciated. So in terms of a plan, like as said, it's set to auto plan if you ask for it on any time a PR is submitted. So it will just go, it looks like you've changed the DNS record in this project. I have a glob match that goes, if something changed is here, set this as the root directory for Terraform and just run a plan in there. So it'll pass my Atlantis configuration, figure out what to do, lock the project, and then run Terraform plan, as you can kind of see down here. In terms of applying, essentially the same kind of thing. So you just see output, it basically does the same. Goes into that directory, checks if there was a plan file generated previously, and applies it. So it makes the changes for me. If your workflow is non-standard in any way, how would you accommodate this? I have a slightly comical example in a sec from my last job. But basically, like if you need to pull credentials on the fly, like if you're using AWS Vault, it's sort of, you can add in steps for that. So like if you don't have credentials in your environment and you need to pull them every time you need them for Terraform for any reason, you can handle that kind of stuff. Like if you need to run specific cleanup commands, anything like that, you can handle that in most of them in different ways. Terraform Cloud only allows you to, I think, pull down static binaries from places and run them, and kind of discourages you from doing anything fancy. But M0 and Atlantis support custom workflows pretty well, it seems. So what was I doing here? So I didn't have time at a particular place to figure out the IAM policies. So I had to reuse one that was tied to actual users, and that had 2 FA enabled. So I'm using this to generate STS tokens so I can assume a role, jump into that, then generate a 2FA code, push that back in, and then plan. So I've kind of got this generate token step at the top, and then running like TFM install, which you don't need to do anymore, and then planning and applying a set. But I've kind of modified the entry point so I can handle that stuff on boot. And then literally doing this. So I'm unsetting my keys, overwriting them, and then running a Python script which generates a 2FA code and then pump that back in. So if you have weird workflows, you can do it. I highly don't recommend you ever do this, but if you need to do it, you can do it. So let's take a look at some actual examples. I've talked enough. You probably want to know what this looks like, or fall asleep. I don't know, either or. So end to end, I'm just going to make a change to something in a DNS file. I just did it to this because it's like probably one of the most benign resources that we have in our infrastructure. Also, the sandbox is basically my playground, so I just do whatever I want in it. So I make changes to that file. I've removed a record, commit that in, push it up. As a kind of caveat, I have edited a bunch of these, so if stuff looks either abnormally fast or if it's jumping around, it's because I forgot how to use a mouse or it took a long time. So if you remove that record, create a PR, looks pretty normal to most people. And you see that an Atlantis plan comes up. So webhook fires off from GitHub, tells Atlantis to do something, and eventually it'll comment back with the output. So picks up that I destroyed stuff, calculates that against remote state. I'm going to pull this record out. How do I get it to do it? So there's Atlantis plan and Atlantis apply comments. You can comment back on a PR, and Atlantis will only pick up on those 2 things. It should then comment back with what it's decided to do. It's not going to do it because there's no applies on it. So I got another user to approve it. Approval's good. So like my apply requirements for this PR have been fulfilled. So let's apply. You'll see the apply starts churning again after it had failed. And then I've got kind of various things like automatically merge on successful. And then on the actual repository itself, I've got like that kind of stuff set up. So that should kind of give you an example of how does that work end to end. So now like that now matches up, remote states updated, good to go. All run from a container. So in terms of how the locks work, so we've got an existing record on the left. So I'm going to try and submit another PR to do something else there. So add that, commit it, push it up again as before. I couldn't type, as you can see. So take a look at that, open another PR as if someone else would do. Because they're not necessarily going to check if there's locks outstanding. And then that will churn away for a little bit and you'll essentially get a failed plan. It tells you there's a failed plan because there's an outstanding lock. And this is literally the only thing that the UI shows is what locks are currently enabled. So it's not particularly useful, but it will comment back on the PR regardless that that's kind of what's gone on. And it will point you to the PR that you need to get approved. So like if you need to push people towards that to like get their stuff pushed through, that's kind of how you could find out. In terms of N0, if you wanted to create an environment, so I've got this kind of repo, same repo hooked up already. I want to create a new environment. It will pre-calculate a workspace name if I don't supply one, and then create essentially a carbon copy of the code that I have in this project, just specifically for me. All of these steps are specific to M0 in a lot of cases in terms of setup. So that's what I mean by it will capture the state that's output here and store it within itself, as opposed to your chosen remote state backend. So like, it'll just take a look that I want to create these two storage buckets, plop that out. Oh, sorry, Brad, I realized I didn't get around to answering your question. I'll say to summarize that, how is what Atlantis does different from what is called GitOps? That is a question that I am not qualified to answer, but it's a good question. So skipping on from there. In terms of M0 workflows, so like being able to create extra workflows on top of each other is nice, but like, you know, if you're going to actually pull this into a PR workflow, how does it actually work? So not exactly in the same way as Atlantis. Like, so I'm going to make changes to a file. I've essentially told M0 to watch for changes on a branch that I'm merging into. So the base branch you see here is M0. So I'm going to say, I'm going to remove one of these buckets. I'm going to put up the PR for it. So it will work out that I've submitted a PR that has changes that are like compared to the base branch that I've told it to watch. After a little bit of time, you see, so it shows up as a PR plan type. So you can click into there and essentially just like whirls away on that. And then eventually it'll tell you what's going on. So comments back in the same way as Atlantis. So saying, I've got one thing to destroy. I'm going to delete this bucket for you. I've got the PR approval, but different to Atlantis, it's not going to actually apply it now. So you see there's no changes here. I'm going to actually have to merge it. So it only applies on the branch you've told it to watch. It'll only comment on what it plans to do on PRs that are against that branch. So that's just kind of a conceptual difference. As I said, whether that's preferable or not depends on your workflows, depends on how you and your team and your organization work. But then you'll see here, like now that it's merged in, it's just going to run changes as normal and then plot through it. But I mean, in terms of UI, like M0 has the nicest UI by far. It is a little glitchy at times, but as I said, it's a really new product. So I think they've probably got a lot of stuff they want to do with it. So it has a lot of potential. And then that is that. So Terraform Cloud looks kind of similar in the way that you kind of create stuff to M0, but not based on workspaces unless you pre-configure it to. So, and as I said, it uses its own Terraform Cloud backend, known as an enhanced backend. I think it's the only one other than local. And in terms of creating environments, works kind of the same way. You pick what project you want. It will run plan and applies for it with an approval step. Come on, internet. Had to fail me at one point. There we go. All right, so if you want to submit a PR against something for Terraform, so similar kind of thing, I told Terraform Cloud to watch the base Terraform Cloud branch. I'm going to push a change up for that. You'll see there's no changes right now. And then I'm going to delete the bucket, create a PR. It will go through. And you see on the status check, there's got a pending plan. As I said, it won't put feedback on the PR itself. It will just show it in the status check. You need to get that then approved. Similar to M0, it's not going to run it until it's merged in. So it only tells you what it plans on doing, not what it's actually going to do. So see that that was like a plan only. And then this will then wear away, get the actual stuff. But in this case, the approval step is here in Terraform Cloud. I don't know off the top of my head if you can set up notifications for this to go out separately, but it's essentially the same thing. It's just a bit more disjointed. That's the only kind of thing to bear in mind. So same kind of approval steps exist, but you can then still end up with bad code in master, depending on your workflow. So advantages and drawbacks. Advantages of PR-based automation is that you can get contributions from people that are not you. In particular, for some people on my team at work, not working with Terraform day in, day out, it's kind of nice to be able to chuck up code which they know to be syntactically correct, but not actually need to have, all their authentication set up, all their environment set up, like be good to go. They can just kind of make a quick change, like they need to quickly change an IP on a DNS record. It makes it easy to do that kind of stuff. Having PR review before execution is really handy because in a lot of cases, most people will apply stuff and then put up a PR when it's good. I'm exceptionally guilty of that. So that's kind of nice, kind of have more of a standardized workflow. Because it's version control based, that ties into a lot of your other automation usually. So can kind of make like a nice kind of flow in that case. It potentially decreases credential theft, but it also increases credential theft. So you're issuing less permissions throughout your organization for people, because in theory, people can just reuse credentials that are within the central executor, but for obvious reasons, you can see how that's a problem. And in theory, you can relieve some of the bottlenecks of like a piling issue list of, I need to do this. Like, let's just throw all this stuff to the one team that's capable of doing it. So kind of building automation for that kind of digs you out of that a little bit. Like not entirely, because if there's any problems on the plans or that they need to create net new stuff, you're probably going to have to get involved, but hopefully it can reduce some of the toil. Or I found it reduces enough of the toil for me for it to be useful. But your mileage may vary entirely depending on what you're doing. So disadvantages of doing it, the feedback cycle is slow. So if you're kind of developing like day to day, or you want to kind of like test out a module, I wouldn't use Atlantis or any tool like that equivalent to do it, because you got to like commit, push, wait. It's kind of a lot easier to prototype that stuff out locally, I found. So less ideal for making new modules. You're moving security controls from strictly provider control potentially to version control, which may not be desirable. Like if you're relying on GitHub, like pull request approvals to make sure the stuff goes through or not, that may be less desirable, kind of depending on security model. One of the biggest ones, which freaks out our security manager a little bit, is if you got into Atlantis, you would have a bunch of credentials to do a bunch of stuff. So that's what I mean. You got to weigh up the pros and cons of, is handing out a bunch of credentials to a lot of people and making sure that they're like rotated, withdrawn and appropriate, versus having something that has more credentials in a single spot. Like there's pros and cons to both. And also if you're running it yourself, it's something else you've got to maintain. So why did we choose Atlantis? One reason is it's open source and free to use. It's primarily maintained by Luke Kaisal, who works at HashiCorp. So like they've got a fairly decent vendor kind of tie in there anyway. And it's got a lot of frequent contributions. So it's pretty well maintained. In terms of all three, it's probably the simplest, and it gives you a lot more flexibility in terms of how you configure it and how you run it. So that's just what works for us. But as I said, there's a lot of other pros to the other two tools as well. So I've talked a lot. So in summary, Atlantis, as I said, is open source and thus free to use. It's very customizable. It's the only free solution that runs on premise. And from what I can make out, it's the only one that will give you a approval stages pre-merge, which is nice. M0 is entirely cloud hosted, and it's really easy and quick to get up and running. And especially for short-lived environments, it's probably the best tool for that. Terraform Cloud is just a whole platform solution, really. So it offers way more than the stuff I'm talking about, especially in terms of being able to hook into remote execution just from running locally. So that helps out with like credential sprawl as well. But yeah, it does a lot, and I don't think it's strictly a fair comparison here to say like pick Atlantis over Terraform because it's better. It's not better, it's kind of just different. And that's it, and that's me. So I'm an infrastructure engineer at PartnerStack. We are currently hiring, as I posted in the link right at the top. This slide deck is available at that URL. And that's it. Thank you very much for listening, everybody. Yeah, let me know if you have any questions. I think we've got a little bit of time, but I'll leave Steve to take care of that. But yeah, thank you very much.
Yeah, thanks a lot, Andrew. This was great, very comprehensive. I love always seeing comparisons of options, right? I think there's so many choices out there that seeing someone's decision practice and their thought process and the pros and cons behind their decisions is super valuable, because we can all go read stuff on the internet, but having someone's like real life experience, choosing the right tool for the job, and having that kind of thought process made in public or shared publicly, I think is awesome. And that's exactly the kind of thing that we like to see at the meetup. So thank you very much for that. I am aware that we're at 6 p.m. ish. So coming into 6 p.m., just want to remind everybody, we're doing it again next month. Next month is distributed tracing with Daniel Spoonhauer. I've put the link in the chat, but it's in the same place as always. And we will be letting everybody know in Slack. And if you've got to run. But I did have one question for you, Andrew, if you could stick around for a minute. I was looking at all these approval steps that you can put into this process, and I wasn't, maybe I missed it, but is there a way to have those approvals kind of piped into Slack so that they can be surfaced to multiple people in a channel and then answered in chat? Or do you always have to be going into the tool to do your approvals?
I think for Atlantis, at least, you kind of have to rely on like GitHub, GitLabs facilities for that. I want to say you can rig things up in Terraform Cloud to work like that. Like I know they've got a Slack notifier that will tell you about what's going on with specific plans and applies and things like that. Yeah, so I think it does have a more comprehensive solution. Something like Terraform Cloud is better to either configure that, or I think it's easier to build it because like they've got webhook capabilities. So if you had kind of more non-standard things where you wanted to pipe notifications to or call out notifications, I think you could do that. Mm-hmm. But yeah, for Atlantis, it's just like I have the GitHub app in Slack that notifies me when people approve. So like I got a couple of pings this afternoon for someone on my team just approving something. So I could just kind of hop in there, type Atlantis apply, and off to the races. But it's a little less automated.
Is it? So you're getting a notification when there's an approval completed. Are you also getting a notification when there's an approval requested?
On PRs, yeah. So I have myself set as code owners on just some of the project files. So it automatically tags, I think, one of 4 people on a PR. So it's not necessarily always me, but usually it will ping someone that is expected to know whether that Terraform is correct and whether the output of a plan is correct, to take a look at it. So that's kind of how we handle it. Does that scale? Not necessarily. That's why I think kind of platforms like Terraform Cloud, where you can create a bit more of a comprehensive workflow, probably makes sense in larger organizations.
Cool.
Yeah, ours is very small scale. Someone will chuck up a change. Someone on my team will take a look at it, take a quick peek. If it looks good, approve it.
It's nice while it lasts.
Yeah, we'll see. Well, hiring's up and down. So yeah, we will see. It'd be nice to have the problem of there's hundreds of engineers, but
right. Yeah, it's nice to have too many resources to draw on and too many people to wrangle. Anybody else have a question for Andrew?
I actually have one. You mentioned some pros and cons of using these systems, and I noticed that a lot of them were talking about credentials. Doesn't that just ultimately get solved by using Vault? I kind of feel like they're trying to force you to use the two in conjunction with each other. So for instance, like I'm doing a little bit of this, and in my pipeline, I have like just variables for the password that are from Vault, or in my case, like a GitLab hashed thing. And that kind of, I feel like that gets rid of a lot of the cons in this infrastructure, because the passwords sit behind a Vault rather than just being in plain text in your code.
Oh yeah, 100%. I'd agree with that. If you've got Vault in place, that solves the same kind of problems for the same kind of reasons, I think. So yeah, I would love to have that set up to be able to just pull stuff on the fly. Yeah.
I think that's like every nerd's like, I want to do this eventually project is get Vault running.
Yeah, it's been my to-do project at 3 places. And I mean, we had it running at my last job, but we weren't really using it. Like, not how I would want to, not to actually have like dynamic credential rotation, stuff like that, which is what I really want.
For me, like from my perspective, it's easy to push that project down the road because it's scary, right? I mean, it deals with credentials. It's kind of nice to have the thing that you know that's comfortable, even if it's painful. If you can wrap your head around it and it's, you know, what it looks like from start to finish, it's kind of easy to stick with that instead of jumping into new territory.
Yeah, I am probably just going to jump on the HashiCorp cloud, like hosted Vault beta. I think I really want to see what that's like. Like, I love Vault, but setting it up and managing it, I don't have the time. So it'd be nice to see that.
Cool. Any other questions? All right. Well, we're after 6. I'm going to call it and let everybody get back to their lives. I'm going to thank you, Andrew. It was a pleasure, and it's always great to see you. Thank you very much for contributing. Anyone else who's interested in giving a talk, we've got the next couple months booked up, but we're looking at the summer. So if you've got a project that you want to hit, if you've got something that you've wanted to learn, one of the best ways is signing yourself up for a talk. You will learn that thing that you want to talk about. So Andrew can attest to that. A lot of us speakers can attest to that. It is, it's learning. It's actually learning the easy way, I find, because it's very motivating when you've got a talk to deliver. But if you're interested in that, or if you want a hand with putting a talk together again, reach out to me. I'm happy to lend my support in any way that I can. But with that, I will say thank you to everyone. Thank you, Andrew, again, for your generous sharing. And we will see you all next month, and we'll see you in the meantime in Slack.